all, I would like to say hello, teacher and everybody. Today I will present about hashing function, and in this presentation, we cover on five main part. And now move to the first point, hashing. And what is hashing? Hashing is a technique to convert a Reynolds key value into Reynolds indexes of the array by using hash function and the value stored in data structure that we call hash table. And we use hashing because hashing provide fast data retrieval, uniform distribution, and data integrity. Anyway, hashing is used with database um, to enable items to be retrieved and more quickly. And what is hashing function? Hashing function is a function that can be used to make data or some arbitrary size to precise value. And to create it, we follow by the formula hash k equal to k multi-size. And with k is the input value, and t size is table size of some array. And now take a look at example of some hashing function. Some formula, we calculate that hash 10 equal to 10 mod 10 equal to 0, and then we put 10 to hash index of 0, and for all of the input we follow by the same way until all of the input value. And the third point is collision resolution. For this point, if we calculate by hashing function and it has the same hash index, that's why we need to use collision resolution. To collision resolution, we can solve it by the two main way. The first point is open addressing. Second point is separate chaining. And in open addressing, we have three methods such as linear probing, quadratic probing, and double hashing. And to clarify each point of it, move to my member to clarify about it.
Now it's on my turn to continue from my classroom. This point we focus on the linear probing. What is linear probing? Linear probing is a scheme in computer programming for resolving collision. It has table data structure for maintaining a collection of the key value pair and looking up the value associated with the given key. And we can calculate linear probing by formula below. A of k equal k multi-size. This is a general formula to calculate linear probing. To make clear and easy to understand, we can look at the example to show linear probing that use formula above. We have 5 design and we have 5 number to input there, and 31, 23, 52, 63, and 200. Now we choose the first number is the 31. To find have index by using general formula to calculate. We put the number 31 into the formula, we get 31 modulo 5, we get have index number 1. Now we can store number 31 to the have index number 1. Now next we input the number 23 into the formula, we get 23 modulo 5, we get have index number 3. Then we store number 23 to the have index number 3. And we input the number 52 into the formula. We get 52 modulo 5, we get have index number 2. After that, we can store number 52 to the have index number 2. Now we put the number 63 into the formula. We get 63 modulo 5 and we get have index number 3. This is a special point because we get have index collision. Mean that we have the same have index between 63 and 23. Now we can use this formula. H1 of k equal ak plus 1 modulo design. We use design number 5 the same. Calculate until it stop have the same half index, but our new half index is number 4, don't have duplicate half index. Now we can store number 63 to the half index number 4. Now we have one more number is 200. Now we put it into the formula. We get 200 modulo 5 and we get half index 0. Now we can store number 200 to the half index 0. That's all for my point. Now let's my classmate to continue to explain this point.
Let's talk about quadratic probing. What is quadratic probing? Quadratic probing is an open addressing scheme in computer programming for solving hash collisions in hash table. It operates by taking the original hash index and adding successive value of an arbitrary quadratic polynomial until an open slot is found. In quadratic probing, we calculate hash key by using formula. To calculate hash index, we use hash k equal k modulo t psi. If slot is full, then we try to hash 1 k equal hash k plus multiply 1 by 1 mod t psi. And we will do this until the slot is available. To apply this formula to our example, okay, let's see together. For example, we have t psi equal 5 and input equal 31, 23, 52, 63, and 200. Now we substitute 31 equal modulo 5 equal 1, 23 modulo 5 equals 3, 52 equal modulo 5 equal 2, and 63 equal modulo 5 equals 3. This part collision actual collision with 23 by using of by following of using formula. We got a new hash table is 4, and the last one is 200. 200 modulo 5 equals 0, and we will take all the remain of hash table by sorting in hash table. Now the next point is double hashing.
Move to the double hashing function. And what is double hashing? Double hashing is a collision resolving on a pan addressing. It uses the idea of applying the second hash function to prevent the collision is actual. Double hashing is the collision that use prime number to have. So then we move to the formula of hashing function. Before we go in, we must explain about two steps of calculation. Step 1. Define two hash function. In this case, it had main formula ak equal k mod t psi, and the second formula is a of k equal prime subtract k mod prime, where prime is smaller than t psi. Let's do the calculation. Step 2. To assess the calculation of hash index, we using the main formula. If it have the duplicate key of ak, we must try solve function below again and again until not duplicate key. By using a1k equal ak plus 1 multiply ak mod t psi. Please move to the example. We input file number 31, 23, 52, 63, and 200 with the t psi equal 5 and prime number equal 3. For the first element, 31. We input 31 modulo with 5, we get index 1, and move 31 to the hash index 1. And for 23, 52, we can skip it because it's the same calculation with line 31. For 63, it had a good point. We input 63 modulo with 5, we get index 3. It had a duplicate key like key 23. So we can use the second formula. 81 or 63. After we calculate it, we get the index 1. And move 63 uh, uh, get the index 1, but it had a duplicate key again. So we must move to the H2 of 63. After calculate it, we get the index 4. It is 3. So we can move 63 to the hash index number 4. And the last number is the 200. And we import 200 modulo with 5. And we get index 0 and move the 200 to the hash index 0. So now please move to the new presenter.
In this point, talking about secret chaining. And what is secret chaining? Secret chaining is a portion in the hash table has list to handle collision. And secret chaining is defined as a method by which linked lists of values are built in association with each location within the hash table when collision occurs. So let's see operational algorithm. Calculate hash using hash equal car mode design. And secret chaining use linked list to place the element at the end of chaining according the hash index. Let's move to example. We have file size and file data. The first we insert 31. We receive index number 1 after we calculate with function hashing. So move data 31 to index 1. And next insert 23 and receive index number 3 and move data 23 to index 3. And next 52 has received index number 2, so move 52 to index 2. And 63 is received index 3 and its redundancy with data 23 in index 3, so it is conclusion with 23 and the flash is next to 23. And the last one is 200 and we receive index zone, so move data 200 to index 0. So we see at a hash index table and index number 4 is empty data. So in secret chaining has some slots are free and some slots has 2 data is linked list. And next we compare with addressing and secret chaining. So number 1, open addressing requires more computing and secret chaining is simpler to implement. 2. In open addressing table may become full and secret chaining has table never fill up. We can always add more elements to chain. 3. Open addressing requires extra care to avoid clustering and log factor. And secret chaining is less sensitive to the hash function or load factors. 4. Open addressing is used when the frequency and number of keys is known. And 4. Secret chaining is mostly used when it is unknown how many and how frequently keys may be inserted or deleted. And 5. Open addressing provides better cache performance as everything is stored in the same table. And for secret chaining, cache performance of chaining is not good as keys are stored using English. And 6. Open addressing is a slot can be used even if an input doesn't map to it. And for secret chaining, wastage of space and some part of chaining table in Chinese are never used. 7. Open addressing, no link in open addressing. And for secret chaining, use extra space for link. All these compare open addressing and secret, and we know about formula open addressing and formula for several chaining. So we can build hashing function by yourself or follow by addressing and several chaining. And next point, move my member.
Section number 4 is determining the key to hash. The main idea of the point is about to minimize the number and find their uniqueness. The ultimate method that I'm going to talk about is folding and string-based key hashing. Folding is when the key have to divide it into several parts and each part will be summed together, then we will get a new number. Let's take a look at the example. We have an identifier number 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we divide it into three parts and sum each part together, and we get a result as hash of 1, 2, 3, hyphen 4, 5, 6, hyphen 7, 8, 9 equal 1368 multi-sign. And we can do it another way is use the number above and divide it into three parts, reverse the second part, and we get the result is hash of 1, 2, 3, hyphen 4, 5, 6, hyphen 7, 8, 9 equal 1566 modulus t psi. The second point is about string-based key hashing. A string can be transformed into an integer by converting its character into integer and add together. As you can see the formula in the slide, and move on to an example. If we have hash of string hello and we do it that way and then sum it together for the loss t psi. Time to conclusion. Hashing is used to index large amount of data. Address of each key. Calculate using the key itself. Collision. Resolve with open and close addressing. Hashing is widely used in database, indexing, compiler, caching, password authentication, and more. Insertion, deletion, and retrieval occur in constant time. Our presentation comes to the end. Thank you for paying attention.